In this lesson, we are going to review limit of a function as x approaches infinity, and we talk about asymptotes of rational functions. Our focus is horizontal and vertical asymptotes. Let's review what we've done when we discussed limit of f of x as x approaches infinity. For polynomial functions, limit of p at x, whether x approaches positive infinity or negative infinity, is the same as limit of the dominant term as x approaches infinity. This means the end behavior of a polynomial function is the same as the end behavior of the function which has only one term, and it is the term with the greatest exponent of the polynomial. We used the same thing and we found limit of a rational function as x approaches infinity. It is the same as limit of the dominant term of p at x divided by the dominant term of q at x as x approaches infinity. Usually when we find the limit of p at x over q at x as x approaches infinity, we use this rule. If the degree of the denominator is bigger than the degree of the numerator, then the limit is 0, because the dominant term of the denominator is more. When we reduce it, we have x at the denominator of the fraction. When the degree of qx and degree of px are the same, we have the ratios of the leading coefficients of each polynomial, and if the degree of qx is less than the degree of px, then the limit would be infinity. Let's have a couple of examples. For example, limit of x approaches negative infinity of negative 5x4 plus 6x3 plus 8x2 plus x plus 1. This limit is the same as limit of negative 5x4 as x approaches negative infinity. Any negative number to the power of 4 is positive, times negative 5 is negative. And as x approaches negative infinity, x4 approaches infinity. So this limit is negative infinity. Limit of 2x2 plus x plus 1 over 3x2 plus 2x minus 1 as x approaches positive infinity. The dominant term of the numerator is 2x2, the denominator is 3x2, therefore the limit is the same as limit of 2x2 divided by 3x2 as x approaches infinity, which is 2 over 3. Or we could use the rule that we mentioned above. The limit when the degree of the numerator and the denominator are the same is the ratio of the leading coefficient. Limit of 2 plus 1 over x plus 3 over x2 plus 5 over x3 as x approaches infinity. When x approaches infinity, 1 over x approaches 0. 3 over x2 approaches 0. 5 over x3 is also approaches 0. Therefore, this limit is 2. Let's talk about asymptote. X equals a is called vertical asymptote of the graph of y equals f of x if limit of f of x as x approaches a is infinity. When x approaches infinity, the graph of the function and the asymptote, the vertical line, are getting closer and closer. Y equals b is called horizontal asymptote of the graph of y equals f of x. Then limit of f of x as x approaches infinity equals b. It could be positive or negative infinity. For example, for function y equals 2x minus 1 divided by 3x plus 2, limit of y as x approaches infinity is 2 over 3. Therefore, y equals 2 over 3 is the horizontal asymptote of the graph of the function. Limit of y as x approaches negative 2 over 3 from a little bit smaller than negative 2 over 3 is definitely infinity, but we want to see if it is positive or negative. When x is a little bit less than negative 2 over 3, the denominator is negative, the numerator is also negative, then this limit is positive infinity. Similarly, limit of y as x approaches negative 2 over 3 from positive side is negative infinity. Therefore, y equals negative 2 over x equals negative 2 over 3 is the vertical asymptote of the graph of this function. Let's have a couple of examples. Limit of 2x3 minus x minus 1 divided by x plus 1 as x approaches negative infinity. This limit is the same as limit of 2x2 as x approaches negative infinity. Notice that 2x3 is dominant term of the numerator and x is the dominant term of the denominator. When we reduce it, we have 2x2. When x approaches negative infinity, 2x2 approaches positive infinity. Therefore, the given limit is positive infinity. The second example, limit of 3x3 plus 5x2 minus x minus 1 divided by 2x3 plus 4x2 plus x plus 2 as x approaches positive infinity. Since the degree of numerator and the denominator are the same, the limit is 3 over 2. Question number 3. Limit of x over x2 plus 3x plus 1 as x approaches negative infinity. The degree of the denominator is more than the degree of the numerator, therefore the limit is 0. Example 4. Determine the equation of the asymptote of y equals 2x2 minus x minus 1 divided by x2 plus 1. Limit of y as x approaches infinity is 2. Therefore, y equals 2 is the equation of the horizontal asymptote. The function does not have any vertical asymptote since y cannot be infinity. Notice that the denominator of the function, x2 plus 1, has no real root. Let's recap. In this video, we introduce the horizontal and vertical asymptote of a function. If limit of f of x as x approaches infinity is b, y equals b is called the horizontal asymptote of the function. The graph of the function as x approaches infinity is getting closer and closer to the horizontal line y equals b. If limit of f of x as x approaches a, this can be from bigger side or smaller side, is infinity, x equals a is the vertical asymptote of the function y equals f of x. This means the graph of the function is getting closer and closer to the horizontal line x equals a when x is bigger or smaller than a. Thank you.